Hello and welcome back to the Algebra 1 notes. This is section 2, and this is solving linear equations with variables on both sides. In section 1, we just had variables on one side. So we're going to kind of switch it up a little bit. And what we want to do is we want to be able to explain the steps used to solve a one-variable linear equation having variables on both sides. Okay, solve one-variable linear equations having a variable on both sides using tables, graphs, or algebra. And then pointing out solutions that are variable or not, that are viable or not viable in a modeling context, okay? And then we want to create one variable linear equations having the variable on both sides to model and solve problems. So, first thing we want to talk about here is this problem where you've got these two towns in Colorado, okay? You've got the population for, looks like it's called Berthoud, Colorado. And then you have a population trend for Wellington, Colorado. So your x-axis is the years since the year 2000, and then your y value is the population. Now what you see is that both populations are increasing, okay? And so, you know, if I wanted to talk about the population of Berthoud, okay, we can model it using this function here, p of t, okay? And then we have the population for Wellington by this function. And we want to know, when will the towns have the same population? So where t is the time in years, when will the populations be equal? Okay? And so the question is that if you were to take this graph and put that graph here, okay, and it looks like I can just kind of draw it in here for the most part, and I got a graph that looks like that. We want to know, when are the populations the same? So like around what time frame are they the same? All right, and so that we know, this is just to kind of give us a picture. It looks like it's around like 10 years or so, give or take. Okay, just a rough estimate there. But let's take a look and let's actually solve this equation to see what we get. So what I'd want to do is I'd want to set this function here, 106.67t plus 4,763.67 equal to this function, okay? And that's kind of the trend that we're going to be working with. So let's go ahead and do that. And we're going to take 106. So we've got, let's do this. Okay, I've got 100. I'm going to put it up here so we've got space. 106.67t is equal, plus, so we've got our one function for Berthoud, and that's 4763.67. And we're going to set that equal to 308.8t, and that's plus 2,844.18, so 2,844.18. All right. So now the task that we want to do is solve this for t. Okay. Now what I want to do is identify my like terms. Now I've got this term here that contains a t. Okay, and I have this term here that contains a t. Okay. So I've also got these numbers here. This number 4,763 and 2,844. Okay, now what I'm going to do is I'm going to put all of my variables on the left side and put all my numbers on the right side. Okay, and so what I'm going to do, and actually, you know what, I'm going to do this. I'm going to put my numbers on the left side and put my variables on the right side. So I'm going to do this. I'm going to subtract both sides by 2,844.18. I'm going to subtract by 2,844.18. Okay? And so what I know is that when I subtract these two numbers, this goes away and this cancels out to 0. So now let me rewrite this left side as 106.67t, and then let's actually do the math here and find what 4,000, so we've got 4,763.67 minus 2,844.18, okay? And so this gives us a value of 1,919 So plus 919.49, and this is equal to 308.8 t. All right. Now I'm going to now subtract my term with my variable, 106.67 t, from both sides, minus 106.67 t. Now, when I take something and subtract itself, okay, it cancels out and goes to 0. All right. But if I take 308.8, so I'm going to do 308.8 and then minus 106.67, okay, that's going to give me 202. So I'm going to get 202.13. 202.13, and I'm going to add a t to that, okay? Because this has a t, this has a t. When I combine these like terms, I just add the numbers or subtract the numbers and keep my t. Okay, and I'm going to leave this equal to 1,919.49, and then I'm going to divide both sides by 202.13. 202.13, and we get that t is equal to approximately, 9.496. Okay, and so that's the time frame. Okay, and remember how I said over here that it's about 10 years, after, roughly about that. So 9.496. Now, if it wants to know when will the towns have the same population, okay, and this is years since 2000, what I want to do is I'd want to say, well, that's about between 2009 and 2010, okay, because I can't have an exact year of 2009.496, okay, so that's what we've got. All right, let's take a look at this next problem. And it says that calculating the particular input value. Okay, input, remember, is an x value. All right? So, the tuition costs C for a local community college are modeled by the function C of H is equal to 250 plus 200H, where H represents the number of credit hours taken. The local state university has tuition cost S, modeled by the function S of H is equal to 300 plus 180H. Okay? And so what we want to figure out here is at what point are the tuitions the same? So we would need to write when or how many hours, produce the same tuition cost. Okay, so what we want to say here is we'd want to set one function for tuition, okay, the cost, 250, so let's write 250 plus 200H equal to the other function for the state university, okay? So we've got, and let's write that as 300 plus 180H, okay? Let's go ahead and just solve this for H. And so this one's a little bit easier to solve. The numbers are whole numbers. It's not crazy like the other one. But I want to get all of my H's on one side of the equal sign and all my numbers on the other. Now, it doesn't matter which way you do it, but when I do it, guys, I do it in such a way that I want to make sure that I'm working with positive numbers. So if I were to subtract 200H from both sides, I know I'd get a negative number here. And if I subtracted 300, 250 minus 300 is going to give me a negative number. But if I move the 180H to the other side and move the 250, it'll keep me with positive numbers. So first, let's identify our like terms. Okay, these terms contain H's. I'm going to underline them in red. These terms have no H's. They're just numbers. I'm going to underline them in blue. So what I'm going to do first is I'm going to subtract 180H from both sides, minus 180H. And as a result, we get 250 plus 200 minus 180 is 20H, and that's equal to 300, okay? And then I'm going to subtract 250 from both sides. And so then I get a value of 20H is equal to 50, okay? And so then what I'd want to do is I'd want to divide both sides by 20, divide by 20. and we get that h is equal to 50 divided by 20, okay? And that number, folks, as it doesn't look like it's that, it looks kind of like a big number, but it's actually not. If I divide each of these by 10, okay, then I get that my value for h is really just 5/2, okay? And that is the same value as 2.5, okay? So the number of hours that would produce the same tuition cost is 2.5 hours. So you really wouldn't get that much out of your value. One's going to be ultimately cheaper, and that's going to be your community college is going to be, I think your state tuition's a little bit cheaper, yeah. But that's the number of hours that will produce the same tuition cost, okay? All right, so we've kind of been doing this already where we're learning how to solve linear equations. The first thing is we want to combine like terms on either side of the equal sign, all right? And the important thing is putting those numbers, from one side to the other and being comfortable moving those over, okay? And then use properties of equality to isolate the variable and then check your solution using substitution. So let's just jump in here and let's just solve this linear equation. And what I want to do first is identify our like terms, okay? I've got 2/5 x, a negative 5x, and a negative x, and then I've got a positive 12 and a positive 1/5, okay? Now, the first thing I want to do is I want to combine my like terms. I've got 2/5 x minus 5x, and so I want to combine these two because they both contain an x, and since they're on the same side of the equal sign, I don't have to do that much work. The only thing I will do is let's rewrite this so that we can write this as a fraction and get a common denominator. And I'm going to write 5/1x plus 12 is equal to negative x, and then this is plus 1/5. So what I'd want to do is get a common denominator here, multiply this by 5 and by 5, because I have a 5 and a 1, get a common denominator of 5, multiply this by 5 and 5. So my next step is going to be 2/5 x minus 25/5 x plus 12, and this is equal to negative x plus 1/5, okay? So then if I take 2 minus 25, this is going to give me negative 23/5 x plus 12 is equal to negative x plus 1/5, okay? Now, it doesn't necessarily matter which side we utilize here. But let's go ahead and, it doesn't really matter where we go from here. But in any case, we need to identify our like terms. So I'm going to identify my terms with my x variable here and here, and then the terms without an x here and here. Okay, now what I'm going to do is I'm going to add 23/5 x to both sides. Okay, we'll start with that. So I'm going to add 23/5 x here, add 23/5 x there. Okay, and so I'm going to get this. I'm going to move this up here a little bit. I'm going to get positive 12 is equal to negative x, and let's do this. Instead of negative x, let's do negative 1/1x plus 23/5 x, and then plus 1/5, okay? And so what I want to do is get a common denominator. I'm going to multiply this by 5 and 5, and then we're going to get that 12 is equal to negative 5/5 x plus 23/5 x plus 1/5. Okay, so if I have negative 5 plus 23, that's going to give me positive 18, so we get 12 is equal to 18/5 x plus 1/5, okay? Now what I want to do here is I want to move my other number, my 1/5, to the other side. So we get, let's do this. I'm going to subtract 1/5 from both sides, minus 1/5. All right, so as a result, we end up getting, and let me do this. I'm going to do 12/1 minus 1/5, and this is equal to 18/5 x. Okay, now I need a common denominator here to add these together. So I'm going to multiply this by 5/5. And so this gives us a number of 60 fifths minus 1 fifth, and this is equal to 18 fifths x. Okay, now 60 minus 1 is going to give us, I'm going to move this up here, 60 minus 1 is going to be 59 fifths, okay? And this is equal to 18 fifths x. All right. Now, what I'd want to do to move that 18 fifths, in order, typically I would divide by 18 fifths, but I want to multiply by the reciprocal, which is 5 over 18. I'm going to multiply this by 5 over 18. Now, one thing we need to realize here is that these 5s divide out here and the 18s divide out. So you're left with x is equal to, now over here, the same thing happens. Your 5s divide out, all right? And you're simply just left with 59 eighteenths, okay? Now 59, I believe, is a prime number, so we can't really simplify that. But you've got 59 eighteenths, your value is going to be about, x is approximately, say, 3.27 repeating, okay? And that's kind of the idea, okay? I would prefer this. But guys, I know this is a lot of work. I know it doesn't look very good, but we need to be able to solve these equations with fractions. Now, I am showing you a significant amount of steps, okay? If I were to do this problem, I wouldn't show as many steps. I do a lot of this kind of work on the side, but guys, I want you to be able to make sure that you know how to do this. And, I think rewriting it and going from one step to the next is really important. Now, hopefully you've written all this stuff down and you can explain what happens from one step to the next. I do everything, every step I do with a purpose. And hopefully you start to see that trend and, we're able to, go from there, all right? So let's go ahead and take a look at this next equation, okay? This one's a little bit easier because it's got whole numbers, so no fraction work. So, same number of terms, look at this, same number of terms as this one, but look how many less steps it's going to take because there aren't any fractions, okay? So let's take a look at our like terms. I've got negative 7x and negative 2x and 13x, and then I've got positive 12 and 23. Now what I'm going to do is I'm going to combine negative 7x and negative 2x. And so this is going to give me, because they're on the same side of the equal sign, I don't have to move it to the other side. All right, so I'm just going to get negative 9x. Okay, plus 12, and this is equal to 23 plus 13x, okay? Now, it doesn't matter which way I go, which one I move, we're going to end up getting a negative number. I can just tell by looking at it, but what I'll do first is I'm going to add 9x to both sides. Okay, so add 9x to both sides. And then I get 12 is equal to 23 plus 13 plus 9, which is going to give us 22, okay? So this is going to give us 22x, all right? Now, so I've moved all my x's onto the right side of the equal sign. I'm going to move all my numbers to the other side. So the first thing I'm going to do is subtract 23 from both sides, okay? And so if I take 12 minus 23, that's going to give me negative 11, all right? So this gives me negative 11 is equal to 22x. Okay, now since I'm multiplying by 22, I'm going to divide by 22 on both sides. And x is going to give me negative 11 22nds. I can divide each of these numbers by 11. And this is going to give me x is equal to negative 1/2. And that's it. That's my value. Okay, so, look at that. Look how many fewer steps that took to arrive at our answers and then say up over here, okay? This just had fractions, okay? So you got to manipulate a lot of numbers. I still get the same, I still get an answer, but we just need to make sure we're working through it. Okay. I'm going to go ahead and skip over this question. We're going to look at this one in class. So go ahead and get started on your assignment and get started on your quiz, and we'll see you soon. Thanks. Bye.